PeopleSoft gets hit by a 0-day. npm changes what code is allowed to run during install. GitHub removes long-lived personal access tokens from agentic workflows. And Anthropic reminds everyone that your AI dependency can disappear for reasons that have nothing to do with uptime. The theme this week is simple. Default trust is getting punished. Old enterprise systems were trusted because they were internal. Package installs were trusted because that is just how the ecosystem worked. CI/CD tokens were trusted because they were convenient. AI models were trusted because the API worked yesterday. But production does not care why you trusted something. It only cares what that trust was allowed to do. I'm Brian Teller from Teller's Tech, and this is Ship It Weekly. Welcome back to Ship It Weekly, the show where we look at the DevOps, SRE, cloud, platform, and security stories that actually matter when you are the person who eventually has to keep the thing running. This week is about default trust. We're starting with Oracle PeopleSoft and a 0-day that was reportedly exploited before Oracle released an emergency patch. Then we'll talk npm v12 changing install script defaults, which is great for supply chain security and maybe a little annoying for some CI pipelines. After that, we'll get into GitHub Agentic workflows no longer needing personal access tokens, which is the kind of boring credential change that actually matters. Then we'll talk about Anthropic disabling Fable 5 and Mythos 5 after a US export control directive, because AI model availability is now also a policy risk dependency. In the lightning round, we'll hit Tecton Cloud Events moving to a dedicated events controller, NVIDIA Triton 26.04 changing inference server defaults, AWS Nitro isolation engine using formal verification, and Homebrew 6.0 requiring explicit trust for third-party taps. The human closer this week is about trust defaults, because a lot of incidents start with one quiet assumption. The system is internal. The package is fine. This token is safe. This model will be there tomorrow. And sometimes that assumption is the real production dependency. So let's get into it. First up, Oracle issued an emergency advisory for CVE 2026-35273 in PeopleSoft People Tools. And yes, I know, PeopleSoft does not sound like the kind of shiny cloud-native story that makes people sprint to the podcast app. But that is exactly why it matters. A lot of modern companies still depend on older enterprise systems for HR, finance, payroll, student records, supply chain, and all the boring data that becomes extremely exciting when attackers get it. Oracle says that the vulnerability is remotely exploitable without authentication and can result in remote code execution. Public reporting says exploitation was observed before Oracle's emergency advisory, with Shiny Hunters linked activity targeting mostly US organizations, especially higher education. So the shape of the story is pretty clear. Old enterprise application, sensitive data, remote unauthenticated exploit, active exploitation, emergency patch. That is a bad combination. And the lesson for DevOps, SRE, platform, and cloud teams is not just patch PeopleSoft. Although, yes, obviously, patch PeopleSoft. The bigger lesson is that the enterprise app tier is still part of your perimeter, even if everyone emotionally moved onto Kubernetes. A lot of teams have a weird relationship with older enterprise platforms. They are important enough that nobody can turn them off, but old enough that nobody really wants to own them. They live in a special network zone. They have a special upgrade window. They have special vendor requirements. They have special firewall rules from 2017 that everyone is afraid to touch. And somehow, because they are enterprise apps, people stop thinking of them like internet-exposed production systems. Attackers do not care what generation of architecture the system belongs to. They care whether it has data, access, and a path in. PeopleSoft may not be the cool part of your stack, but if it holds HR data, finance data, student data, employee data, or business workflow data, it is very much part of your attack surface. This is also a good reminder that legacy does not mean low priority. Sometimes legacy means high value, hard to patch, badly isolated, and full of data. That is not low priority. That is where an attacker brings a shovel. The practical takeaway is simple. Know where these systems are. Know whether they are internet exposed. Know who owns patching. Know who owns logs. Know what normal access looks like. Know whether unusual agents, web shells, or scheduled tasks would actually be noticed. And if you are a platform or cloud team that thinks this is someone else's problem, be careful. Because during the incident call, someone else's problem has a funny way of becoming, why did nobody know this existed? Your ERP systems, HR systems, finance systems, and admin portals are production systems. Treat them that way. Second story, npm version 12 is changing some defaults around install scripts. And this one matters to developers, platform teams, CI maintainers, security teams, and anyone who has ever watched an npm install do 12 things they did not explicitly ask it to do. GitHub says npm version 12 is expected in July 2026, and one of the big breaking changes is that allow scripts will default to off. That means npm install will no longer execute pre-install, install, or post-install scripts from dependencies unless they are explicitly allowed. Prepare scripts from Git, file, and link dependencies are blocked the same way. These settings are already available in npm 11.16.0 for migration testing. This is a big ecosystem shift. For years, npm install has been more powerful than people like to admit. You run the package install. The package runs code. That code might build native bindings, download binaries, generate files, patch something, bootstrap something, do the magic that makes everything work. But that same install time execution path is also a supply chain attack surface. A malicious package does not need your app to import it at runtime if it can run code during install. It only needs to land in the dependency tree. Then the CI runner, developer laptop, or build machine does the rest. This is why this change matters. It moves the ecosystem from implicit trust towards explicit trust. And yes, that is good. But some builds are going to break because a lot of pipelines have been relying on install time magic without documenting it. Native modules, post-install downloads, Git dependencies, file dependencies, link dependencies, internal packages, packages that compile, packages that generate code, packages that do one tiny little install step that nobody has looked at since the person who wrote it left the company. Those assumptions are about to become visible, and visibility is great. Right after it ruins your Tuesday. The practical takeaway is not panic about npm version 12. The takeaway is to test early. Run builds with the new behavior before it becomes the default. Find which dependencies need scripts. Decide which scripts you actually trust. Document why. And do not just flip everything back on because one pipeline failed. That defeats the point. This is a chance to clean up dependency trust, especially in CI. Ask what install scripts run today. Ask whether CI runners have secrets available during install. Ask whether build steps can reach internal services. Ask whether developers are running installs on machines with cloud credentials, SSH keys, or package publishing rights. Because the blast radius of an install script is not just the package. It is whatever the install environment can access. I like this change. It is going to annoy people, but sometimes the annoying default is the correct default. npm install is finally getting less magical. And that means that some teams are about to discover how much magic they were depending on. Third story. GitHub says agentic workflows no longer need a personal access token. And yes, that sounds boring. But boring credential changes are often the ones that save you later. Previously, agentic workflows needed personal access tokens in certain setups. Now, GitHub says these workflows can use the built in GitHub Actions token and the Copilot request write permission instead. The point is to avoid creating and storing long lived personal access tokens for agentic workflows. This matters because agentic CI CD is already risky enough. These workflows can read context, generate changes, open pull requests, review code, call tools, interact with repo state, and eventually, in some environments, they may become part of release, remediation, triage, or automation paths. So the credentials they use matter a lot. A personal access token is often tied to a person. It may be long-lived. It may have broad permissions. It may sit in secrets. It may get copied between repos. It may survive longer than anyone intended. It may still exist after the workflow changed, the person changed teams, or everyone forgot why the token was created. That is not a great pattern for agentic automation. A scoped workflow token is not magic. You still have to configure it correctly. You still have to review permissions. You still have to think about which events can trigger the workflow. You still have to worry about untrusted input. But it is a better default than handing an agent a long-lived personal credential and hoping everyone remembers where it lives. The platform takeaway is simple. If you are experimenting with agentic workflows in GitHub, review the whole trust model. What repos can run it? What events can trigger them? What permissions do they get? Can pull request content influence the agent? Can issue comments influence the agent? Can the agent write code? Can it approve changes? Can it call external tools? Can it see secrets? Can it publish artifacts? Can it affect production? And are you still using personal access tokens where you do not need them? Because agents are not just assistants once they enter CI/CD. They become automation surfaces. And automation services need boring, strict, reviewable credentials. So yes, use the better GitHub auth model. But do not stop there. If it can change code, trigger work, or spend money, it belongs in your production automation threat model. Fourth story. Anthropic published a statement saying that the US government issued an export control directive requiring Anthropic to suspend access to Fable 5 and Mythos 5 by any foreign national, whether inside or outside the United States, including foreign national Anthropic employees. Anthropic said that the net effect was that it had to abruptly disable Fable 5 and Mythos 5 for all customers to ensure compliance. Access to other Anthropic models was not affected. Now, this is not a normal SRE outage. There was not a regional failure. There was not a bad deploy. There was not a database incident. There was not a capacity problem. But for customers who depend on those models, the effect is still operational. The dependency disappeared, and it disappeared for policy reasons. That is the lesson. If AI APIs are part of your production path, dependency risk is no longer just uptime, latency, quota, and cost. It is also model availability, geography, export controls, regulatory shifts, vendor policy, safety policy, commercial access, model deprecation, compliance interpretation, and whatever new category we invent next quarter. This is uncomfortable because AI dependencies can be harder to substitute than people pretend. You can usually swap one HTTP endpoint for another at a code level. But can you swap the behavior, the context window, the latency, the tool calling behavior, the moderation behavior, the cost profile, the prompt format, the eval results, the customer experience, the internal workflow? The fallback may not be use a different model. The fallback may be a degraded mode, a smaller model, a cached response, a human review queue, a simpler workflow, a feature flag, a regional restriction, or a message that says this capability is temporarily unavailable. Boring fallback behavior is better than waking up to discover your product path depends on a model that is no longer available to you. The practical takeaway is to add AI models to your dependency register like any other production dependency. Track which features use which model. Track whether the model is in a critical path. Track where your users are. Track fallback options. Track whether you can degrade gracefully. Track whether a vendor-side access change would be an incident. And test the fallback. Do not just write fallback to another model in a doc and call it done. Actually try it. Because the weird thing about AI infrastructure is that even when the API shape looks portable, the behavior is not. Your AI dependency can disappear for reasons that have nothing to do with uptime. That means your reliability plan needs to cover more than outages. Now let's do a quick lightning round. First, Tecton pipelines changed how cloud events are sent. Cloud events for pipeline runs and task runs now move through a dedicated Tecton events controller instead of the core pipeline run and task run controllers. That means operators need to make sure the Tecton events controller deployment is actually running. Small looking platform changes like this can have real operational impact. If CI/CD observability, event routing, notifications, or automation depends on Tecton events, make sure the new controller is deployed, monitored, and part of the upgrade checklist. Because the new pipeline ran, but the event never showed up, is exactly the kind of thing that sends teams into Slack archaeology. Second, NVIDIA Triton Inference Server 26.04 has changes operators should read before upgrading. Client shared memory is now disabled by default and must be enabled explicitly if you rely on the old behavior. Triton also enforces max in-flight requests as a shared limit across ensemble requests, which is meant to prevent unbounded queue growth in ensemble pipelines. The short version is this: AI inference servers are now normal platform infrastructure. Defaults change. Queue behavior changes, memory behavior changes, model control changes. So upgrade them like production systems, not sidecar experiments. Third, AWS published a deep dive on the Nitro Isolation Engine. AWS says the Nitro Isolation Engine is generally available on Graviton 5 based instances and uses formal verification to demonstrate isolation properties. That is interesting because cloud isolation is usually something customers trust but cannot directly inspect. Formal verification does not mean bugs are impossible, but it does show where cloud providers are heading: smaller trusted components, tighter isolation boundaries, and mathematically checked properties for the parts that protect customer workloads. Fourth, Homebrew 6.0 introduced Tap Trust. Homebrew now requires explicit trust for third-party taps before evaluating or running their Ruby code, while official taps remain trusted by default. This is another supply chain default, changing from "sure, run it" to "are you sure you trust this?" And that is good. A third-party tap can contain arbitrary Ruby. If your developer laptops, CI runners, or Bootstrap scripts use Homebrew, this change is worth knowing about. Some installs may prompt or fail until trust is explicit. That might annoy people, but again, that is the point. Developer tooling is part of the supply chain, and fewer things should get to run code just because they were convenient. The human closer this week is about default trust. PeopleSoft was trusted because it was an enterprise system that had been around forever. npm install was trusted because package managers have always done some magic. Agentic workflows were trusted with personal tokens because that was the easy path. AI models were trusted because the API was available yesterday. Tecton events were trusted to keep flowing. Triton defaults were trusted until they changed. Cloud isolation was trusted because that is the cloud model. Homebrew taps were trusted because developer tooling has historically been pretty casual about running code. Different stories, same pattern. Production risk often hides inside the trust defaults nobody has revisited. The system is internal. The install script is normal. The token is convenient. The model will be available. The event will fire. The tap is probably fine. Those assumptions may be true until they are not. So the practical question this week is simple. What are you trusting by default? Which enterprise apps are still exposed? Which package installs run code in CI? Which agents still use long-lived tokens? Which AI models sit in production paths? Which developer tools can execute code before anyone reviews it? That is platform work now, not just building the shiny new thing, but revisiting the old trust assumptions before attackers, vendors, regulators, or outages revisit them for you. Find the defaults, then decide whether they still deserve your trust. That's it for this week of Ship It Weekly. We covered the Oracle PeopleSoft 0-day, npm v12 install script changes, GitHub Agentic workflows moving away from personal access tokens, Anthropic's Fable and Mythos model suspension, and a lightning round on Tekton, NVIDIA Triton, AWS Nitro Isolation Engine, and Homebrew 6.0 Tap Trust. If this episode was useful, follow or subscribe wherever you are watching or listening. If you are on YouTube, hit subscribe. If you are in a podcast app, follow the show there. And if you know someone dealing with enterprise app security, CI/CD supply chain risk, agentic workflows, AI dependency planning, or developer tool trust, send this one to them. It helps the show grow, and it helps me keep making this kind of content for people who actually live with these systems. You can find the weekly brief at oncallbrief.com and more episodes and show notes at shipitweekly.fm. I'm Brian Teller from Teller's Tech. Thanks for listening. And remember, production does not care why you trusted the default. It only cares what that default was allowed to do.